All right, so today we're going to look at acceleration of a ball rolling down a ramp. We're going to use a couple pieces of equipment that are probably not familiar to us. We're going to use things called a Photogate. And a Photogate, right, is this black thing right here that is basically a small little laser. So when something passes through it, right, it will record on there the time that the object took to pass through that little teeny laser, right? And we've got, in this case, Photogates that are set up on both sides, at the top and at the bottom. So basically what's going to happen is we will take a ball, we'll set it up here at the top. There's a little peg up here that we set it against so we know where we're starting. Then we let the ball go, right? And in order to make this right, we have a Photogate up here at the top, set at 5 centimeters. And then this Photogate will slowly be moved down in position, but then we'll look at, when we set up the CPO timer, which you got the directions in the lab, but you guys, when we get back to school and we use these, you'll learn it again. But basically, this little device can determine and record the time it takes the ball to pass through this gate, as well as the time it takes to get from this gate to that gate. So we're going to have 3 different times we record. But basically, it just looks like this. And then I have those different times, and based on whichever lights are appeared. So here it says 0.672. That's the time it took to get from A to B, right? Then if I looked at just the time when the A button was lit up, it's how long it took to get through that gate at the top. Just the B button, the time it took to get through the bottom gate, and record all those times in a bunch of data. And then basically we would set that up, and then we would move it 10 centimeters and run it again, and we would record all those times. We would just keep recording those times again and again and again. We'd have a full data table that had the times involved when the object rolled, from the stop to 15 to 25 to 35 to 45, and we'd have a measured value at 5. And then we'll take that data and we're going to try to calculate the acceleration of the ball, right? And while you're thinking about analyzing your data and looking at it, you want to think about what's different about this measurements in this lab and the situation at the start with the ball in terms of where we're measuring the first thing, and what it was like with the wheel. When we let the wheel roll down the ramp in the last lab, you're going to want to think at some point, probably late in the lab, when we do a conclusion, you're going to compare those 2 labs and exactly what happened. Now, when you look at your lab data, you're going to want to do the graphs, follow directions, make the graphs that you want to make, and then you want to make sure you are leaving all the decimal places that are in the data, because this thing will measure to the 10,000th of a second, which is a pretty good length of measure. I know it's stated in the lab, but the width of this ball is 1.90 centimeters. You're going to need that at some point to calculate velocity, right? If I took the time, for example, 0.0039 or 0.0391, I took the time it took to get through this gate right here. If I took 1.9 divided by that time, that would be to give me the distance over time that it was right here in this little Photogate. So it traveled 1.9 centimeters in 0.00391 seconds, which is about, 48 centimeters per second. All right? And obviously, it should be moving faster here. These times, you'll notice, are lower. And the farther it gets down the ramp, the faster it's going, the quicker it gets through that gate. So those are just some things to consider as we look at the data. So you look at that, and then we'll start our lab analysis today. And then we'll have tomorrow in class, you guys can ask questions. You can email me questions later. It's pretty tedious, the procedure. When you do the procedure and you're writing up your lab report, you can just summarize the steps that are there. You don't have to repeat the steps of connect Photogate A and put it at 5 and connect it in tab A with a cord, and then put B at wherever location and connect it to the CPO and plug the CPO in. You don't need to do all that. You just need to summarize what we're doing. We are measuring the time using Photogates as a ball rolls down the ramp at various distances in 10-centimeter increments, right? With an initial measurement at the position at x equal 5, right? So that's where we are today. You should have the data and that lab report. Read through the lab report, especially when you get to the analysis. I'd read through it before I started doing anything, and make sure you have an understanding of what's going on. Email me, ask me questions about that, and then make sure you answer all the questions in there. You should be able to download the document. You should be able to put all your stuff in there. You should be able to copy and paste your graphs in there when you need to make them. Then you should be able to answer all the questions in writing, and then you can resubmit that electronic document up into CTLS when we get to that point. It's not going to be due probably till the Wednesday of next week, and so we'll be in good shape there. So make sure you're just on it, and that's where we are today.